All right, hello HBS. This video is to help walk you through how to draw the alveoli graphic organizer. So copy this into your lab journal if you haven't already. Trust me, your work does not need to be perfect, and these will probably look just like grapes when you draw them out, but that is totally okay. Okay, so the first thing we're going to do is label all of these structures up here. So the first thing that I want to label is the bronchiole. And I'm sorry for how atrocious my handwriting is going to be. So these tubes right here are the bronchioles. And what they do is transport air, from the bronchi specifically into these little balls, which are called, each individual one is called an alveolus. And then multiple of them together are called alveoli. So alveoli is the plural of alveolus. And then the last thing that we need to label is this kind of squiggly looking connection thing, which is the capillary bed specifically. Okay, so first of all, make sure that those are labeled. I am going to erase my doodles just because it will make things a little bit easier for later, but just remember that these long tubes are the bronchioles. Each individual ball right here is an alveolus, but then multiple alveolus together are alveoli. Okay, so the purpose of the alveoli in general are to help us to do gas exchange, right? And so we know that our body needs oxygen, but just like our body needs oxygen, we have to get rid of carbon dioxide. So for the sake of this diagram, the first thing that we have to do is label the direction in which the blood is flowing. So let's just say that the blood is flowing this way. And if the blood is flowing this way, then that means we are going to have red blood cells going in this way and red blood cells going out this way. You might see on some documents that red blood cells are referred to as erythrocytes. That's the exact same thing. Okay, so when blood gets to the lungs, normally if it's just coming from the body, it's going to be deoxygenated, right? It hasn't received oxygen yet. That's why it's going to the lungs. So all of this part of the capillary bed over here is going to be full of deoxygenated blood because it hasn't yet been oxygenated, which means that this side in the red is going to be oxygenated blood. Okay, so keeping that in mind, we have to track how each different gas is flowing through this structure. So deoxygenated blood will arrive at the lungs first because, of course, it hasn't been oxygenated. That's why it's in the lungs. And then it gets oxygenated by the gas exchange in the alveolus. So the first thing that I want to do is label the direction of oxygen. I feel like that's probably the easiest thing to label. So these tubes right here, remember, that is the bronchioles. That's how we take air in. So in these directions right here, it says that we need to use a green arrow. Oh, using the wrong one. We need to use an orange arrow to show how, this is as orange as it's going to get, how oxygen molecules are moving from high to low concentration. So when we breathe in, we are taking in a bunch of fresh oxygen molecules, right? So these tubes, these bronchioles right here, are going to be full of oxygen. Going to have a high O2 concentration. And then before we've, done gas exchange, the low concentration will be over here because we have deoxygenated blood, right? So what's going to happen is this high amount of oxygen is going to diffuse into the capillary bed where there is less oxygen. And then, of course, once that happens, it's going to flow this way because now we're going to have a high amount of oxygen, right? Because molecules always move from high to low concentrations. It would kind of be like if I took everybody in the class and tried to shove us into a box. You'd be very uncomfortable. In that scenario, each student would be a molecule, and you would be crammed together, super highly concentrated inside of that box, and you'd be uncomfortable and you want out, right? Molecules are the same way. They want to spread out. And so all of this high concentration of oxygen in the bronchioles want to spread out. They don't like to be close together. So they see this lovely capillary bed that doesn't have a lot of oxygen in it, and they spread out, and it becomes oxygenated. So the opposite thing is going to happen with carbon dioxide. And you can see here is where it says to label that in green. So oxygen and carbon dioxide have an inverse relationship. So where we have a low amount of oxygen, we are going to have a high amount of CO2. And CO2 is bad for the blood because it makes the blood acidic. So we need to get it out, or else, acidic blood can have so many different effects on the body. That's why it's so important for us to get rid of CO2. So I'm going to draw the CO2 where it's highly concentrated in this deoxygenated blood. And of course, it wants to get out, right? So if it's highly concentrated within the capillary bed, it wants to move to a space where it's less concentrated, which in this case is the bronchioles. So it's going to move out. I'm just drawing that arrow on the side because I already doodled the oxygen concentration. So over here, where we have a high amount of oxygen in this oxygenated blood over here, I guess I should label that. This area over here will also have high O2. We're going to have a low amount of carbon dioxide because we got rid of that gas by essentially exhaling it out of the bronchioles and into the bronchi, then out your mouth and into the air. So that is how you should label this graphic organizer. I hope that was helpful. Just remember, if you remember anything, that molecules always move from high to low concentrations.